welcome to my workshop. Today we're going to move towards or closer to 3D engraving. We're going to do some experimentation in acrylic plastic, because acrylic plastic shows up, I suppose, the engraving process or the cutting process of a laser beam better than any material. If you remember back in video 212, we cut these out of MDF. It showed up pretty well, but it still wasn't clear as to exactly what's going on. And you do have to understand exactly what's going on with the beam and the step over of the beam and the grayscale cutting performance of the laser. I've just started to do a swatch. Now I'm going to expand on this and cut this test card in the acrylic plastic, and we're going to see what comes out of it. I'm going to put it under the microscope and examine it carefully, because we need to understand, like I say, how the laser cuts into material to be able to perform the process of 3D engraving in material. Okay, so what we're doing here is I have my test card that has individual squared panels of, should we say, dot matrix at different levels. So what I want to do is, or what I'm doing is, the dots or scan lines are set apart 0.1 millimeters. And this one's 0.2 millimeters. And I'm going to do a third one now, and that will be 0.3 millimeters. So what I'm going to do is, first of all, put some handles around that one, right click, then array copy. So we want to make a copy in the Y direction, so we put 2 there, so it'll be this one plus an additional 1, gap 5 millimeters, and we say OK, and one will appear. Now let's put it's actually there, it's okay. Okay. Actually, let's just move it around. Oh. Move it down slightly so it's nice and square. That'll do. Now then, this at the moment is on one layer. There was some confusion when I mentioned about layers and the colors down here. Now, each one of these little colored squares depicts a separate layer, or it enables me, or the program, to individualize each item here. So what we're going to do just that. First of all, we're going to take this one is on that black layer, and that's okay. So now we're going to put this one on a different layer, so we can set the parameters of the machining of this, or the etching of this, at a different level. So we're going to say we want this on a blue layer, and then this one we want on a red layer. So you notice up here now they're different layers, and we will alter these to engrave, engrave. Okay, so we've got 3 engraved layers now, and they are all set. They're set at the same levels, 300 millimeters a second, and power level. Well, I'll show you what the power level is now in a second. But first of all, we're dealing with the black layer. The black layer is 300 millimeters a second, bi-direction, which means the laser is going to fire in the left and right movement or direction. Engraved blowing, yes. Okay. Minimum power of 12, maximum power of 20. Step over 1, that's 0.1 millimeters scan line, step over. And we're going to say down to the top. That means it's going to start this end and work its way that way. That's preferable with a laser because the air, the extraction air, is flowing from the front of the machine to the back. So it means that as you are cutting, the vapors and smoke are being taken back this way, and then you're cutting over or getting rid of any of the dust or debris that is behind the cutter. It's just preferable to do that. So let's calculate this. Okay, now we're going to do the blue layer. Double click that. This one is, we're going to put this one at 0.2, step over or scan gap. I say step over because that is the phrase normally used as a tool progresses through material. But scan line is fine too. And calculate that. And the third one, .3, and calculate that. So now we're going to send it to the machine. So you press download, and then this actually goes to the machine. I now have to fire the machine up before this will actually light up. See, it's grayed out at the moment. When I fire the machine up and it registers its datum area, this will come alive. I will have to get out of it. I'll show you that. So we'll start the laser up. And it's just going to its datum. Okay, download. So now you see this is nice and black now. So the laser controller and the computer are reading each other, and it comes up here saying communication successful. Download, download. And it's in. Cross out of that. Oh, just one other thing that I will show you. Now if I circle that or put handles around it, right click, then size. You'll notice the size here. So it's 50.8 millimeters in length and 25.4 millimeters in width. There are 25.4 millimeters to an inch. So what I've actually done in a metric system, I have made this exactly 2 inches by 1 inch. That's important because we are talking about resolution of the dot matrix here, right? Which is the actual, it's the spot size, spot gap, scan line, step over. All this is going to come into the DPI of a 3D carving or picture. DPI is dots per inch, and we are going to discover here which is the best dot per inch 2-inch lens that we have in this laser. Okay, so I've jogged the nozzle now over to where I think the start position is going to be, and I've set the datum there. So now we'll just run a test, which means just run a square over the outside of where the laser is actually going to cut, just to make sure that we are indeed in the right position. Okay, I've just repositioned it now, and we'll do another test. That looks a little better. Now then, let's start. Okay, so this is fresh off the laser. This particular one here, the step over is 0.09. So this is the finest step over that we've used so far. And 0.1, 1.5, 2, 2.5, and 3. So first of all, we're going to examine these. So the swash starts off at white. This is a grayscale image. This is how the laser actually depicts then or machines a grayscale image. So it starts off at white, where the laser doesn't fire at all, and then gradually as you go to black, this is 100%. So we're now going to examine these and paying attention to the step over, the beam step over. Okay, so the first one here, you can see the laser just starting to fire here. I'm going to zoom in a bit. Okay. I will do my best to actually show you this, because it's we're working at a microscopic level. This is a electronic microscope. It's not necessary for you to have one of these, but it does come in handy if you want to fully understand what the laser is doing. So this is starting off at white. And you'll see that the laser fires an odd spot or two now and again, and it just gets greater and greater and greater. Sometimes it's elongated, or a double fire, or a triple fire, but in other cases it's single single firings of the laser. The laser works on a similar principle to the old type of black and white television screens, or indeed the earlier type of color screens, where you had a similar to a laser in the back that was firing a dot that was scanning the whole screen 16 times or 32 times per second, and the dot was very similar size. It was about actually 0.5 of a millimeter, somewhere like that, and it got lighter and darker, and that's how it made up a black and white or color picture on the cathode array tube. It's the old type of black and white TV screens. These LED screens work on an entirely different sort of method. Anyway, sidetracking a bit. Now then, so as I push this on through, you can see that as the laser would depict a whiter color or brighter color from grey to black, as the color gets darker, obviously the firings of the laser gets more closely packed or denser, until we get to a situation where it is white, completely white, which means the exact opposite, that this would be black. And you can see that the actual laser, you can detect the actual laser beam here as it cuts off, and you can just about detect that the scan lines of the laser that it's cut are butted up against each other, so it gives full coverage. This is 0.9 of a millimeter step over. Sorry, it's not. It's 0.09. So now here we go to 0.1, and you can see that there is not much. Let me turn this around a bit so that I can get it underneath the microscope. There's not that much difference between this one, which is 0.09, and the next one over, if I can get to it, there we go, which is 0.1. There's not that much detectable difference. Even if you go further out, you really can't, there's no real difference to us, to our eye, that we can see that, you know, there's not much difference at all. This particular one is, if I can get it under, I can't get it under any further than that, I don't think. Oh, if I turn it sideways I can. Okay, this is 0.15. Now you can actually detect that there is a very, very, very small, tiny gap. Incidentally, I will tell you that each one of these scan lines of the laser is about the size of a human hair. So this is the size we're looking at here. So the gap in between is what, tenth of a human hair? In actual fact, I shall put my finger here on what we're looking at. We're actually looking at that, and it's impossible to detect any lines in between. But you can see that there is a difference between this and this. So let's just move on to the next one. And what we're paying attention here to is the scan lines and the gaps between, you know, the laser rather lines and the step over. Now it's quite defined that there is a definite gap now between the scan lines, and this is 0.25 and 0.3. I'm just going to get the Graticool a minute. That is the little device that tells you exactly, or gives you an indication of size. First of all, I've got this it's a 6-inch roll. Okay, it's got graduations on here. It's 32, 16th of an inch and 64th of an inch, and also the millimeters. So I'm going to show you a comparison now. Okay, so okay, so if you can see a 64th of an inch, okay, each one of those divisions is a 64th of an inch, so you're familiar with that. Each one of these divisions is a millimeter, and this is half millimeters. Oh, if I can hold it steadily enough. So each one of these small divisions is a half millimeter, and from here to here is 1 millimeter. So, and it's still too big to actually understand how small these are, as it were. Okay, here's a definite comparison here. I've lost where I am. There I am, somewhere. Here we go. Okay. What we're trying to do here is gauge the size of our laser. And there it is there. So the size of our laser track then is 0.076, or as close to it as we can be, and the step over is the step over is nearly the same there. So I'm not really sure how that comes about, but there it is. Let's have a little look. 0.1, or is 0.1 closer? That looks to be closer to me. Hard to make the comparison. No, I think actually, there we go. Now 0.76 is probably the nearest. It's less than 0.01. Oh, sorry, 0.1. I believe so. Anyway, it's so minute that it's not really worth splitting hairs about. So that's the level that we're working down to. And why I'm showing you this is because this step over and the size of the laser track then, or burn mark, becomes very important. Now I am going to move now to the next one, which was our test card, which is what you can sort of pick out easier the different levels of should we say changing colour. So this is white. This is be regarded as white. I think those little marks are just pieces of dust and what have you that are floating around the workshop here. This is what the laser cut. This is the first square, and we're going now to the second square, and you can see there's a defined line from one shade to the next shade of colour. Push that card underneath, it's probably easier to see as we move to the next shade of colour. So what we are determining here is the laser can work at a minute level right down to 0.1 of a millimeter. The step over can be defined just at 0.1 of a millimeter. That's this one here. This is back at 0.1 of a millimeter, where you can just make out that the track marks or the cut marks of the laser are just touching each other. They melt into each other, but they don't, should we say, interfere with each other as much. So this is the highest resolution that we could etch into a piece of material, and obviously then as you go out to 0.3, then it gets a bit too coarse. You can actually detect that, and in real life you can feel it, and you can just see it with your naked eye. So what we are determining here is that between 0.09 and 0.1 is probably the ideal situation for etching and also 3D engraving in acrylic, that is. It may turn out to be the same in wood as well. This, by the way, is the viewing. If I can get it a little crisper than that, I'll try. It's about as crisp as I can get it. Now this is viewing the laser cut at 0.09 step over. This is viewing from the top of the cut. This is the actual surface that the laser cut. Now I'm going to just turn it over and show you an interesting something. Looks a bit fuzzy. Look at that. It's much more defined, and that is why when you etch into a piece of acrylic plastic and turn it around the other way, it looks so much sharper and better. You can see that this is now the reverse side. This is the shiny side, and the etching has been carried out on the other side, and it's much more clearer because you're actually seeing or viewing the bottom of the cut. Okay, I've just taken this into maximum magnification. This is now at 500 times magnification. Let me just see if I can, that's it. That's the absolute largest that I can get it. That is now 500 times magnification. It's a bit snowy because I suppose that's the interaction between the microscope and the operation of the screen of the display here, but that gives a very graphic, I think, understanding of what the laser is actually doing. And this is traveling at 300 millimeters per second. Fantastic view there. Okay, so I think we'll draw this video to an end now, because it's going to start to get a little bit too long. Next time we come back, I think we'll do our first attempt at a three-dimensional cut. I think it'd be fair to do a separate video for that altogether. So long as we get an understanding of the step over and the power settings of the laser, and when you alter step over, the actual results that you get. And it's easier to split the videos up like this. It's easier for you guys to watch things and I suppose understand them a bit better. So I hope you've enjoyed the video. Please come and see me on both of my channels, on Australian Inventors Workshop and Australian Inventors Laser Lab. So until next time, thank you for watching and bye for now.